Welcome to Principal AI System Design Videos. We make AI-specific system design videos to help you become a better engineer and prepare for the job interviews. Please subscribe to our channel and like our videos. We also have a newsletter and a blog. Sign up for regular updates and exclusive premium content. In today's video, we are going to design an Instagram-like feed generation system using generative AI models. Feed generation is a common problem, and traditional machine learning technologies such as collaborative filtering, etc., have been very effective. But here we are specifically asked to use LLM-like models to produce the feed. Here is a problem statement. We are told that we are building this system for a small company and cost is a factor. We are not given any additional information other than the fact that we have to use generative AI technology and design for simplicity and cost. Like any system design interview, we start with functional requirements and ask interviewer thoughtful questions to gather more details. Generally, good idea to clarify the scope of the problem. For example, we make sure that we have to only design the feed generation system and other systems such as authentication, user modeling, etc. are already present. Social features like likes, comments, etc. already there. Secondly, what are the features of a good feed? It should be relevant, be related to people user follows, and fresh. It should also be infinitely scrollable. We then get told that we should also remember to design it in a way that it is possible to experiment and measure performance. Once we are done with the functional requirements, we move on to non-functional requirements. Here, typically clear out what is the scaling impact. Ask how many users, how many daily active users, how the traffic looks like, and the storage requirements. For example, we are told that we need to assume 1M daily active users. A user follows 500 users on an average, and each photo is less than 1 MB. This is all helpful information. We can also ask how many posts each user makes per day, etc. We are also told that the feed must be generated in 3 seconds. Now, in a system design problems, computing such latencies is hard. What 3 seconds really means here is that the feed should be fast. We are not told any qualitative metric here, so we can sacrifice feed quality for speed whenever we are faced with a trade-off. Always start with high-level design. Get the simple components right. Make sure your interviewer agrees with your high-level design. In our case, a feed is eventually served using some API. This API will be used by our clients, such as mobile devices or web browsers. For users' posts, we will store the assert on a CDN by storing it in a cloud file system, such as Amazon S3, but for the post metadata, we will have a NoSQL database for post metadata. Each image will have to be post-processed to extract information, optimization for storage, etc. Besides posts, we also need to store relationship between users, such as follow relationships. This can be stored more efficiently in some kind of graph-optimized database. Amazon Neptune is an example of such database. Since we have been asked to generate the feed in less than 3 seconds, I think it is best to pre-compute it and then serve it. So we need some quick storage for the pre-computed feed. When it comes to pre-computation, there are 2 approaches. One is where we always pre-compute with a fixed priority. In second approach, we rely on more staggered approach where for some we pre-compute aggressively and keep data in memory, while for some we keep it in persistent storage, and for some we don't compute at all. We will show only one storage layer here, but it could be designed more complex than that. So, when a request from client hits the API gateway that mutates either the posts or the social graph, this should generate a notification once the mutation is committed and then added to a message queue. This message queue is an input to the pre-computation service. We have 2 design choices here, push model and pull model. In push model, the mutation events on posts and social graph would create notification for the pre-computation service that will incrementally build an update field for every user. There are 1 million active users, so we need to generate at least 1 million feeds per day. In push model, we very proactively generate the feed, but we also do it incrementally. This is efficient, but it also means when a celebrity posts something, we might have to do millions of writes for all the followers. The other alternative is the pull model. We proactively detect the users who might log in into app and then generate the feed for the users at that time right from scratch. The advantage of this approach is that we do the feed generation on as needed basis. This saves computation and storage at the expense of lower speed of the feed. Both these approaches are not mutually exclusive. We can identify users who are more active users and we can build their feed using push model. And users who are inactive or occasionally active users, We can do a pull model feed generation for them. Once we agree that this is a decent high-level design, we can actually look into how to build the computation system at slightly lower level. Our computation system consists of two units. First is a message queue. Message queue will be used primarily for push model of feed computation. For pull model 2, we can have a message queue that receives some notification that a user might be about to get active. This can trigger feed computation. The message queue is read by a pool of worker machines. Each machine reads a message possibly sharded on userid. The notifications on this queue could range anything from uploading of new posts to liking a post or commenting, etc. The worker will look at every such mutation and update a vector database entry for the user. We translate every image post into, say, a bag of words that describes the image, each like as user's preference for a specific type of image. The actual data modeling here is going to be driven by product and the ML researchers, but broadly, we need a vector database update here. Vector databases allow us to store embeddings so they can easily be searched. An example of vector databases is LangChain. We also need some sort of config system where the employees of the company could specify various config parameters for vector database storage. What do we want to store? How to experiment with effective embedding storage? The config system will allow us to do this. Whenever user follows a new user or the people this user follows post something, we need to add this to user's potential feed. This is again an incremental chain, and we can put a hard limit on, say, 1,000 chronological posts being stored in the database. This update happens continuously. In case of pull model, our workers will pull posts and other info from database during feed generation time. Very likely, these will be big queries, but less frequent queries. Once a worker has all the info it needs, it can then build an effective feed from that data. As I said earlier, we don't have to choose between push and pull. We can start with, say, pull model and then simply also implement a push model. Now let us get to the heart of the problem. How do we generate a relevant feed? We create a recommendation service. The recommendation service takes the vector database queries as input, uses an existing trained model, and returns a response. There are two inputs to the recommendation system: the chronological posts of the users that the user follows, then some of the trending and relevant posts for the user so user could discover new content. Both of these contents will come from the vector DB. Once the vector DB provides an output, this can be added to a model to provide a better ranking system. The model needs to have an experimentation system so that we can deploy different models for different users and measure effectiveness of each model by measuring its impact on the end result. We need to decide what our North Star metrics are to measure effectiveness of a recommendation system. One could be the average duration of session of a user. It could also be clicks or comments or likes. It is ultimately a product decision to find the right balance, but once we have the right metrics, we can add experiment ID to all the events of interest and segment the metrics based on the experiment ID. Thanks for watching. If you have any questions, please ask in the comments. I will be glad to address them. Please subscribe the channel for future video notifications. Also, subscribe to our newsletter that has more exclusive content.